Okay, let's do another example similar to the previous one when we need to find the area, or in other words, the definite integral using u substitution and the indefinite integral. So the function this time is ln of x squared over x, and we're viewing this in the interval 1 to e. So I created the graph over here, and mind you, this is not an easy graph to create. You can't really do it. You need a calculator or a computer to do that. But still, you notice that in the interval 1 to e, your function is positive. So the area under the graph is the same thing as the definite integral. So what we really need to find here is the definite integral from 1 to e ln of x squared over x dx. Okay? And this is easy to do with a u substitution. So again, I'm going to forget the fact that it's a definite integral and calculate first the indefinite integral ln of x squared over x dx. Okay? So u substitution for this, let's choose u to be ln of x. If we do that, we'll run into trouble. Okay? Remember that you have various choices. You can choose ln of x squared, you can choose x, you can choose x squared. Okay? Let's choose ln of x squared, the whole thing. Like so. Then let's try to calculate what du is. It's the derivative of this. And the derivative of ln of x squared is 1 over x squared times the derivative of the inside, which is 2x, and then dx. And when you do the computation here, when you do the cancellation, you get du equals 2 over x dx, because this square with that x cancels out. And when we solve for dx, this gives you x times du over 2 equals dx. Multiply with x, divide by 2. So we have to replace this u and this dx into my indefinite integral. What you get is the integral of, the first one becomes u, there's an x, the dx changes into x times du over 2. And since we did the math right, the x's canceled out. So you get integral of 1/2 u du. Okay, let's go ahead and solve this. This gives you 1 over 2 u squared over 2 plus c. Okay, because the antiderivative of u is just u squared over 2. So let's change back into x's. This gives you u squared over 4 plus c. But what we really want is, instead of u, put ln of x squared over 4 plus c. So the indefinite integral led us to this antiderivative. Okay, we'll use the antiderivative without the c and plug in just the two endpoints, 1 and e. So what we really need to find is, from 1 to e, ln of x squared over x dx. And this gives you from 1 to e, well, actually, we'll use this other notation because we've already calculated this. So we're going to use this antiderivative, ln of x squared over 4. And this is evaluated from 1 to e. Okay, so let's plug in e. You get ln of e squared over 4. That's your first term. And then let's plug in 1, which gives you minus ln of 1 squared over 4. Okay. And then this one gives you, let's erase this, we don't need it. So this one gives you, well, this is ln of e squared, right? And ln and e cancel out, and you get a 2, right? And the whole thing squared over 4 minus, this is 1 squared, still 1. Ln of 1 is 0. 0 squared is 0, so that's just a 0. So then you have 4 over 4, which is, of course, 1 again. All right, so my definite integral is equal to 1.